You check this out. One half-life of potassium is 10 days. All right? How much time would have passed after 3 half-lives? Okay, so hopefully you guys kind of remember. You start with something, and then you have a half-life. And then you have half of that material, right? So if this was 10 days, how many days would it occur to have 3 half-lives? 30 days, right? So that would be 10 days. This would be 10 days. This would be 10 days. And if you add up all your days, that's 30 days. Perfect. Okay? If one half-life is 5 minutes, how many half-lives would be in a half hour or 30 minutes? How many half-lives would we have? If one half-life is 5 minutes, how many would we have in 30? How'd you get that? 30 divided by 5, right? So if we had 1, 2, 3, 4, 5, 6, and each one was 5 minutes, you got 30. Does that kind of make sense? Is that kind of reviewing a little bit? All right. Hopefully that's kind of clicking in our mind a little bit. All right. Let's try a more difficult problem, okay? Let's try, what was a more harder one? Let's try number 7 here. Let's try number 7. Here we read this. Radon 222 decays from 100 grams to 12.5 in 15 days. How long is one half-life? Okay, so if we start with 100, what does 100 decay to? What's half of 100? 50. Okay, so there's that. What's half of 50? 25. What's half of 25? 12.5. That's where I'm going to. That was my goal. All right, so if I started at 100, I went to 12.5. So in 15 days, so from this point right here all the way to this point was 15 days. There was 3 half-lives that occurred. How long is each one? 5, right? 5. Because if this is 5, and that's 5, and that's 5, all of those add up to be 15. Does that kind of make sense? It's a trickier one. Okay. And then I'm just going to review one of the graphs at the bottom here. We'll do this graph. All right. I'm going to review just one graph here. Because today we are going to be graphing this. Okay, we're going to be doing a little graphing. So it says, what is the half-life of carbon-14? Well, if you look, if you start at 100% and you go down to 50%, right? That's a half-life. So how much time occurred from this point to this point? Well, 5,730. Does that make sense? All right, reading this graph, if you started here and 50% was here, this much time passed. Okay. After 3 half-lives, what percentage of carbon-14 is left? Well, that was 1 half-life. That's a second half-life. That's a third half-life. What percentage would that be? And it's kind of the same one as the one before. That would actually be 12.5. All right. And to show you, well, if we start off with 100, after 1 half-life, after 2 half-lives, after 3 half-lives, and that's your answer. See how it kind of gets repetitive? All right. All right, so if we look, see, if you started with a 400-gram sample of carbon-14, how many grams would you have after 11,460 years? Well, if we look at this, 11,460 years, how many half-lives is that? Well, if this was one half-life, that would be 2 half-lives. So I need 2 half-lives of 400 grams. 2 half-lives. So if I start with 400, there's 1 half-life. There's a second half-life. So what is half of 400? What's half of 200? That's your answer. That's half-lives. Does that kind of review? We feel all right on that? All right. So today, just got a little review activity, okay? What you guys will be doing is...
Excuse the interruption. Berkeley Huff, would you come to the attendance office, please?
What you guys will be doing is you will get a piece of paper, all right? And I went shopping yesterday. I got my little fun size M&Ms. All right, they're probably a little frozen, actually. They were sitting in the car. Got some fun size M&Ms. You will need 1 pack per, if you're working by yourself, you can work by yourself. But if you want to work with a partner or 2 partners, you just need 1 pack. Okay? Let's see. Ziploc bag and a paper towel. Just in case if you want to eat them, you might want a paper towel. All right. The directions on this is pretty straightforward. You don't really need a bag. All right. It says with a bag closed. You can just keep them in here if you want. Just cut off the top. Sound good? So what you guys are going to do is you guys are going to open up the bag. You're going to roll them. Not roll them, just kind of like flip them up. All right. Anything that has an M side up, those decay. All right. Those became a new material. You're going to put those off to the side. Then you're going to put the remaining ones in. All right. You're going to keep track of how many decayed over time so we can graph it on the back. Pretty cool, actually. All right. You'll get accurate results. Ask why. Why do you think you'll get good results? Maybe I guess. Want to take a shot?
Maybe because it has like a 50% chance.
50% chance, right? 50%, you're going to have M up. 50%, you're going to have M down. Half-lives, right? You have a 50% chance of becoming the new element. Very good. Awesome. Okay, so I will leave these up here. You only need 1 of these per group and 1 packet of M&Ms per group. And we'll be good to go. All right. But if you want to work by yourself, that is fine too. Sound good? If you have questions, let me know. I will set that there. We can get started.